Hello all. In this demo, we are going to see how customers can easily create API endpoints of data sources. From various data sources, API Publisher has the ability to build API on top of tables, views, custom SQL, and stored procedures. As well, we can build API on top of CSV, text, and Excel files. Customers can choose the type of authentication for the API. As well as customers can restrict other IP addresses. Customers can build API documentation for the application. API Publisher provides the option to start and stop the API services. This demo is to publish multiple data sources as API and build documentation for the API. The data sources are going to be Postgres, Oracle, Azure SQL, Snowflake Cloud, Amazon S3, and Azure Data Lake. Using these sources, we will build the get method for reading, post method to write, put and patch for update, as well as delete for remove. We will follow 3 steps during the API Publisher. 1. Create an application. 2. Build API endpoints for the data source. 3. Build documentation for the application. We will see these in demo. Let's log in to DataFins. We will look at Postgres, connections, Oracle, Azure SQL, Snowflake, Amazon S3, and Azure Data Lake. As the first step, we will create an application named Demo App with basic authentication. In the module step, we will create a module named Sales Application. Transaction, Customer, Sales, Account, and User. These modules will help end user to differentiate API endpoints. We will leave it blank for IP addresses. So now the application has been created. Let's create API Publisher from Postgres by providing name, connection, application name, module name, and object type, as well as select the object and save. The object can be a table or view or files, as well as we can use custom SQL or stored procedure. The next step is creating an endpoint. First, we will create a read endpoint. Provide endpoint name and choose API option as get. This will list down fields from source, data type, as well as suggested field name, which is camel case converted field name. This suggested field name is the field end user will see while accessing an API. Customers can change the field if needed. Choose filter fields for an API endpoint. This is optional for get method. And finish. That's it. We will do it for the post method now. Select the fields, and the data of these fields will be inserted into the table. For post, the filter is not applicable. Now we will do it for the put method. Select the fields, and filter is almost like where condition of SQL. Finally, we will do it for the delete method. For delete, field selection is not applicable. Select filter, which is almost like where condition of SQL. Let's create API Publisher from Oracle source. We will be creating endpoints for get and post. Select fields and filter as needed. Select the fields and filter as not applicable. We will create a PI publisher from Azure SQL Source. We will be creating endpoints for get and patch. Select fields and filter as needed. Select the fields, and filter as almost like where condition of SQL. Now we will create a PI publisher from Snowflake Cloud. We will be creating endpoints for get and post. Select fields and filter as needed. Select the fields and filter as not applicable. Create a PI publisher from AWS S3 to read CSV file. For get, select fields and filter as needed. Create a PI publisher from Azure Data Lake to read Excel file. For get, select fields and filter as needed. That's it. We have built around 12 API endpoints from various data sources in minutes. Now let's generate API documentation for the application. Run the application and view the Swagger. Here is a quick view of the endpoints and methods. This Swagger can be shared with end users for the documentation of the API. These API endpoints can be tested here in Swagger or can be tested in Postman or in any other API tools and programming. A quick check on the API endpoints with the authorization. Since this has been defined with basic auth in the application, provide a username and password which are defined in the application. DataFins provides other authentication as well. Check some sample get method to see if the data is coming from API which gets from the table. Since we have added ID as a mandatory filter field during endpoint build, we need to provide ID in execute API so we can see the results. Now let's validate the API against table data. We are going to do the following operation from API. We will read the data for ID as 1. Update the record which has ID as 2. Delete the record which has ID as 3. And add a new record with ID as 5000. Let's check for ID 1. We can see API return matches with table data. Now we will update ID 2. We can see the table is retrieving the data which we sent from API. We will delete ID 3. While rerunning SQL, we don't see ID 3. Finally, we will do post, which will add new records in table. While rerunning SQL, we can see a newly added row. We will validate the other database as well. Let's check with Snowflake Cloud. We will check the AWS S3 and see how the data is coming from file. These APIs can be stopped at certain times. This start and stop can be handled through Datafin Scheduler as well. One of the use cases might be that if the data load is happening, we can stop the API to avoid a dirty read. Let's stop one of the APIs and try Swagger. We will test get method for the stopped API. This should throw an error message as API is not active. There you go. We can see the error. Now if we switch back to active and run again from Swagger, we could see the data coming from the table. Let's also check how the authorization works if we provide the wrong ID or password. After changing the wrong password, if we execute, we should get a 401 error. Let's check now. Here we go. We can see error for unauthorized. Now we learned how API publishers can help customers to build API from various sources. Thanks for watching this video. We will see you in another Datafins video.